The normal distribution has a mean, median, and mode that are all equal under perfect conditions. In real life, you get a data set, it's never going to be perfectly having the mean, median, and mode all be the same. This is what the bell-shaped curve looks like. The mean, the median, and the mode are all here because the mode is the number that repeats itself the most. The mean is the mathematical center, so it should be the center of your graph if you were to add up all the values, for every, it's kind of a calculus question, but the median is at the 50% mark. They all land right here in the center of the distribution. So we call this symmetric because you can cut it down the middle. You can make a vertical slice and it makes the same graph. This is not uniform. Uniform looks something like this. Uniform would be like the number, like if you roll a dice 200 times and you count up the number of ones, number of twos, number of threes, number of fours, that looks more like this. Okay, 1, 2, 3, 4, 5, 6. That's a uniform distribution. Every option is the same. Look, getting a z-score of like -3 is way different than getting a z-score of like 0.5. You get a way higher chance. So that's why it's not uniform. Discrete only happens when you have categorical variables. This isn't a category down here, right? If you convert your number to a z-score, then you've got an infinite amount of different options. Z of -2.2, Z of 0.5, 0.55. So this is continuous, not discrete. Non-symmetric, that would obviously be something that doesn't make the same shape when you slice it down the middle. So here's an example of a non-symmetrical distribution. We call this one right skewed because there's some outliers to the right.